Welcome back to Falcon Physician Reviews, Part 4 of the Online Anatomy. This time we'll be discussing twinning through the process of neurulation. We'll start by focusing in on a question. A 27-year-old woman delivers healthy twins. One is 7.6 pounds and the other is 7.0 pounds. There's a male and a female. Examination of the placenta will most likely reveal what features? Hopefully you'll recognize this as fraternal twins, so there should be diamnionic, dichorionic membranes. Twinning in general will be a high-yield thing for you to understand for your board preparation. Twins can develop in two separate ways. There can be one zygote, which will give you identical twins, or two zygotes, which will give you fraternal twins. The dizygotic twins will come from the fertilization of two ova by two sperm, and resulting twins will be of different sex. This form of twinning can run in families and is increased with the fertility treatments that are oftentimes used. So there's a couple red flag issues that you'll be looking for in the stem of questions about twinning. They always have two amnions and two chorions, although the chorions and the placentas can fuse together and be difficult to distinguish as dizygotic rather than monozygotic. This is of course clarified if they are different sex. Monozygotic twins originate from a single sperm and a single ova, and the twins are genetically identical, and this type of twinning is not a familial inheritance issue. This is one of chance. One of the difficulties with monozygotic twins when they share a single placenta is that you can get a syndrome known as twin-twin transfusion syndrome. And this is going to be more common with high multiple gestations. So Octomom had a very high chance of having a twin-twin transfusion syndrome. And what happens in the case of these monochorionic placenta is that they share a blood supply and blood vessels through the connections of the umbilical cords so that their circulations are in contact with one another. And chance will typically dictate that one of them will get more of a blood supply early on in the formation of the embryo than the other, which can sometimes lead to inadequate nutritional or oxygen needs of the second twin that's not getting as much of a blood supply. Therefore, you can either have one twin that's fully resorbed, or you can have one twin that will be either low birth weight or have some developmental issues in relationship to that unequal sharing of those resources. Let's look at specific times of division and frequency with the monozygotic twins. Up at the top we'll have a normal developmental phase and then the type of twinning that occurs at that point. And then at the bottom we'll have what type of chorion, the amnion, and the frequency of these types of twinning. First of all, at the two-cell stage, or the morula stage, very early on after the fertilization process, There's dichorionic and diamniotic twins that can be happening if there's a splitting of the genetic materials in the cells into two separate and developing embryos. This occurs in about 1/3 of the monozygotic twins that are born. At the early blastocyst phase, there can also be a splitting of the materials. So at that intercellular mass can split down the center and form monochorionic diamniotic twins, which is the most common type of monozygotic twinning. And that accounts for almost 2/3 of the monozygotic twins that are born. A third, but very rare possibility is if the bilaminar embryo splits its material in half. And if the bilaminar embryo splits, what you end up with is a monochorionic or monoamniotic twin. And this is very rare and is oftentimes referred to as conjoined twins because there's a high possibility that these two fetuses sharing the same amnion and chorion will actually touch early on and have one component of their body fused together. So this type of twin is very rare and is the one that results in Siamese twinning. After the second week, it's important to note that twinning is not possible. All of those divisions that occur at that point do not have the potency to make two separate embryos. Moving into the third week, gastrulation is going to be an important event. And what happens with gastrulation is that the patterning of the cranial and caudal ends of the embryo is set up. And that's around day 15 with the formation of the precaudal plate and the primitive streak. The precaudal plate will be at the cranial component, and then the primitive node will start as an organizing center to induce the formation of the neural plate and the notochord. As this progresses, the notochord will be pushed forward through steering of molecular signaling, and the notochord will start to make a neural groove, which will then have sides to it, which will fold up and form the notochord, and that will start inducing the formation of ectoderm. At the rostral end, you have the oropharyngeal membrane, and at the caudal end, you have the cloacal membrane. All of this is occurring by day 21 from fertilization. This notochordal process will grow forward from the primitive node, and it will include the ectodermal and endodermal layers of the embryonic disc, and then it will start reaching out towards that precaudal plate. Well, let's put that in different terms. The notochord begins as a group of cells that will ingress as the primitive node starts to form, and then they'll migrate cranially in the midline of the embryo as it forms its central axis. This notochordal process will also help it to acquire a lumen, and the mesoderm in front of the notochordal process is going to be known as the precaudal plate, as an organizing center and signaling center, which will set up the dorsal ventral patterning of the neural tube and the somites. The notochordal floor will fuse with the endoderm. It's important that the regression of the primitive streaks happen as well. And what will happen is that the streak will become restricted to an elevated area at the caudal end of the embryo known as the caudal eminence. And normally this streak should disappear around day 26. The important part about gastrulation are some of the associated problems that you need to understand for your boards. First of all, teratomas are a possibility. They're a neoplasm of the remnant from the primitive streak if it fails to regress. And it's usually the craniosacral region where it's located, and it's 4 times more common in females for some reason than males. Some will contain germ layers, and some will be formed from the primitive streak and will contain all 3 types of cells: ectoderm, endoderm, and mesoderm. And oftentimes teeth, hair, nerve, and bone will be components of these. These are always identified through their pathology. If there's caudal dysgenesis or caudal dysplasias, this also will be an important part of the gastrulation process. One type of disease is the sirenomelia, or that known as the mermaid person. And this happens from a fusion of the distal caudal eminence that never develops. There are several associated issues with gastrulation that can have pathologies that will be from minor to severe, known as the vater or vacteral associated issues. This is really a gastrulation problem, but it will often be accompanied by pathologies that include vertebral defects, anal atresias, tracheoesophageal fistulas, and renal defects. In addition to these, sometimes cardiovascular defects and upper limb defects can be associated as well, which is why the memory tool vater and vacteral, it'd be something useful to know when it comes to gastrulation associated problems. The other issue would be chordomas. This is from a notochordal remnant that's derived from the tumor typically associated around the clivus or the sacrum. And these are more commonly found as a result of inconsequential testing that notices the remnant of these tumors